Chapter 1 Introduction of Case Study.
First of all, we would like to talk about the background of the study. Smoking is a global public health concern and Malaysia is no exception. The prevalence of smoking in Malaysia has significant implications for the population's health, healthcare costs and government policies. This case study aims to investigate various factors related to smoking in Malaysia, assesses the impact of smoking on health outcomes and provide insight for policymakers to address the issue effectively. There are four objectives for this study. First, to determine the prevalence of smoking across different age groups, gender and regions. Second, to identify socio-demographic factors such as income and education associated with smoking. And next, to assess the health outcomes and costs related to smoking in Malaysia. And last but not least, to provide recommendations for targeted public health interventions. Significance of the study. This study is significant as it contributes to understanding the smoking epidemic in Malaysia, which is essential for designing effective prevention and intervention strategies. It also helps quantify the economic and health burdens associated with smoking in the country.
There are 10 variables that we use in this study about the issue of smoking behavior. 10 variables are age, gender, monthly income, number of cigarettes smoked per day, healthcare costs due to smoking, education level, region of residence, smoking status, type of tobacco product use, and presence of smoking-related health condition. Within this variable, there are two types of variables, which are quantitative and qualitative variables. As you can see in the slide presented, I provide you the list of which one are the quantitative and the qualitative. For quantitative, the level of measurement used is only scale or ratio data because it is the most effective scale of measurement and contains a meaningful zero. While for the qualitative variable, it uses nominal data and ordinal data. The only variable used for ordinal data is education level because the data was measured by ranking order, which is low, medium, and high. Graphical techniques provide a visual representation of data, allowing for easy exploration and pattern recognition. Patterns, trends, and outliers are often more apparent in graph, aiding in the identification of interesting features in the data. Use four types of chart, which are bar chart, pie chart, histogram, box plot, and scatter plot. For bar chart, we use variables of region, smoking status, and health condition. For pie chart, we use for gender, education, and tobacco type. For histogram, we use age and cigarette per day. For box plot, we use monthly income and healthcare costs. And for the scatter plot, the suitable variables that we got from the correlation data are health condition and healthcare costs. Health condition we consider as independent variable, while the healthcare cost we consider as dependent variables. The Y variable or dependent variable for the other four charts are all in frequency. Numerical techniques provide precise numerical summaries of data, including measure of central tendency and dispersion. These metrics offer quantitative insight into the characteristic of the dataset. The statistical technique we use is measurement of central tendency, which is mean, median, and mode. We use measure of dispersion, which is to determine the variance, standard deviation, and which. The formula for the calculation are provided in the slide presented. Next, for the measure of position, we determine the maximum, minimum, first quartile, second quartile, and the third quartile. And for the correlation analysis, we need to find the Pearson product moment, correlation coefficient, and coefficient of determination. Finally, we need to calculate for the linear regression. The graphical and numerical techniques aim to provide a comprehensive understanding of smoking behavior and its impact on health in Malaysia. The combination of these methods will help in presenting findings in a clear and meaningful way, facilitating data interpretation and supporting evidence-based recommendation for policymakers and healthcare professionals.
Now, we will continue to the chapter 3, result and interpretation. This chapter have 3 subtopics, which is data presentation, descriptive statistic analysis, and the correlation and regression analysis. Now, we will start with the 3.1, data presentation. Older age group. Reflecting a global trend of aging population, this shift has implications for healthcare, social service, labor force participation, consumer spending, and political influence, emphasizing the need for societal adaptation. This pie chart shows the smoker in the nation. This box plus graph shows the income for the smoker in the nation. The first graph in this slide told us the cigarettes of the smoker taken per day, and the other graph told us the cost of the healthcare to cost of the medical checkup for the smoker. This pie chart shows us the education of the smoker with the 3 level and 3 different percentage, which is high, medium, and low. This bar chart shows us the number of cigarettes taken in the 4 different regions: North, South, East, and West. This bar chart told us 3 different smoking status right now. We have 3: current smoker, ex-smoker, and non-smoker. But the most higher is the current smoker. And this pie chart, it told us 3 types of cigarette, which is the cigarette, the common cigarette that usually people use, and the pipe and the cigar. Lastly, in this data presentation, it shows us the difference between health condition between every people that in nation. Now we continue with the 3.2, which is descriptive statistic analysis. At the upper data, it shows us the descriptive analysis for the age, and below it shows the descriptive analysis for the gender. Right now, I will explain about the descriptive data for the age. The descriptive statistic for the age variable is a dataset of 200 observation given about age range from 18 to 75 years. The mean age is 46, indicating that on average, respondents are in their mid-40s. The standard deviation of age is 16.825, suggests a moderate spread around the mean, supported by a variance of 280.065. A slight rightward skew 0.081 implies a subtle tail on the right side of the distribution. With a valid sample size of 200, this statistic offers a comprehensive overview of the age distribution, encompassing its range, central tendency, variability, and shift. In this slide now, it shows the descriptive analysis for the income and the cigarettes per day. Cigarette per day means the number of cigarettes taken in one day. This descriptive statistic shows the descriptive statistic for the healthcare costs for the smoker. Last but not least, this data statistic told us the statistic for the individual and the region. So this is the last slide for the 3.2. This slide shows the data for the smoking status, tobacco type, and the health condition of the person.
The correlation analysis reveals notable patterns in the data. Notably, health conditions exhibit a significant positive correlation, which is R equal to 0.199, while P is less than 0.01, with healthcare costs suggesting that individuals with more health conditions tend to incur higher healthcare expenses. Considering both correlation strength and statistical significance, health conditions emerges as a robust candidate for the independent variable in a simple linear regression analysis, highlighting its potential as a key predictor of healthcare costs. It's crucial to contextualize these findings within the study scope and theoretical framework for a comprehensive interpretation of results.
From the graph, we can interpret that the scatter plot reveals a discernible but weak positive correlation between health conditions and healthcare costs, underscoring a pronounced financial burden for those with more health issues. The data indicate the significant prevalence of chronic conditions as a public health challenge. An alternative view suggests that higher healthcare costs may signify access to high-quality service, reflecting Malaysia's diverse healthcare options. The scatter plot visually conveys this complex relationship, emphasizing factors such as condition severity and healthcare access that influence costs in Malaysia. For the descriptive statistic, we can interpret that the descriptive statistic of healthcare costs show a mean of 2,632.93 and a significant standard deviation of 1,405.859, suggesting considerable variability in individual expenditures. Meanwhile, health conditions has a mean of 2.50, indicating the average number of health conditions per individual with a standard deviation of 1.182, reflecting the spread in the dataset. This statistic offers crucial insight into central tendencies and variabilities, serving a foundation for further analysis within the dataset. From the correlation table, we can interpret that the correlation analysis between healthcare costs and health conditions reveals a very weak negative linear relationship with a Pearson correlation coefficient of negative 0.051, suggesting a minimal association. The p-value of 0.237 is greater than 0.05, indicating insufficient evidence to reject the null hypothesis of no correlation. In conclusion, there is a weak and statistically non-significant negative correlation, implying a slight decrease in healthcare costs with an increase in health conditions, but the relationship lacks significance.
Next one is model summary. The R-square value of 0.03 indicates that only 0.3% of the variability in the outcome variable is explained by the linear regression model, suggesting a poor fit. The slope and intercept are 0.051 and 1407 respectively, with the slope implying a small change in the outcome variable for 1 unit increase in health conditions. The regression equation is outcome equal to 1407 plus 0.051 multiplied by health conditions plus epsilon, but the low R-square suggests limited reliability in predictions. Caution is advised as uncounted factors may significantly influence the outcome variable. Last but not least is the coefficient. The analysis presents a simple linear regression model for healthcare costs and healthcare conditions. The intercept is 2784.150, representing estimated costs when the conditions are zero. The slope is negative 6.611, indicating a cost decrease in 60.611 units per unit increase in conditions. The standardized coefficient for health conditions is negative 0.051, showing a weak negative relationships. Health conditions coefficient lack statistical significance, which is set equal to negative 0.474, cautioning against strong conclusions. The regression equation is healthcare costs equal to 2784.150 minus 60.611 multiplied by health conditions. The absence of R-square value limits the comprehensive understanding of the model fit. In conclusion, this study has delved into the intricate relationship between smoking behavior, socio-demographic factors, health outcomes, and healthcare costs in Malaysia. Our investigation into smoking prevalence across various demographic groups has brought to light significant disparities. It underscores the necessity for targeted interventions that take into account age, gender, education, and regional variations. Socio-demographic factors, specifically income, education, and region, have emerged as influential factors reshaping behavior of smoking. A little descriptive statistic of our study provide a comprehensive overview of the distribution of these factors, offering insights into contextual nuances surrounding smoking habits in Malaysian population. Moving on, the impact of smoking health behavior focuses on variables like health conditions and healthcare costs, reveal a nuanced picture. While correlation and regression analysis indicate weak and statistically non-significant negative correlation between health conditions and healthcare costs, it highlights a complex interplay of factors contributing to the overall health and economic burden of smoking. The implications of our research extend to public health policy, urging policymakers to design targeted interventions based on the identified influences of smoking behavior. Our study serves as a valuable resource for guiding evidence-based strategies which is aimed at reducing smoking prevalences and improving public health outcomes in Malaysia. However, it is crucial to acknowledge studies' limitations, including reliance on self-reported data and potential recall biases. These limitations underscores the need for cautious interpretation on our findings and emphasize the importance of continued research to address the evolving nature of smoking epidemic. Looking ahead at our future research endeavors could explore additional factors influencing smoking behavior, such as cultural influences and access to the smoking cessation program. Longitudinal studies would provide more in-depth understanding of the causal relationship between smoking behavior, health outcomes, and healthcare costs over time. In summary, our case study lays a valuable foundation for addressing the complex challenges posed by smoking in Malaysia. Policymakers and public health professionals can leverage these insights to craft targeted and effective interventions, fostering a healthier and smoking-free future for Malaysian population. Ongoing research and collaboration efforts will be crucial in sustaining enhancing the impact of public health initiating in the fight against smoking-related health issues. That's all from us. Thank you for your attention and farewell.